Hi, and welcome to 2012 AP Calculus AB free response questions. This is number 2. So the problem gives you a graph, and it shows the lines y equals ln of x and y equals 5 minus x, and their intersection in quadrant 1. Part A asks you to find the area of R, which is the area underneath both curves and above the x-axis. Just a side note, I will be using the TI-84 Plus CE calculator in this video. So we start by using the y equals button on our calculator and plugging in both functions. When you press graph, you should see this, and it's also given to you on the original problem sheet, so you can check. To find the intersection point, press second, calc, and then intersect, which is number 5. It'll ask you along the blue line where the intersection point is. Use your left and right arrows to move the cursor around, and do the same for red and press enter. Then it'll ask for a guess, press enter again, and it should give you the intersection point listed at the bottom of the screen. After you found the intersection point in the calculator, use the x value because the equations are given in terms of x. We need to use two separate integrals because there's two top functions. When we write it out, we have the integral from 1 to 3.6934, which is the x value of the intersection point, and then quantity ln x dx, plus the integral from 3.6934 to 5, quantity 5 minus x dx. The reason we need to split this into two pieces is because there's two top functions. Before our intersection point, ln of x is our top function, and then after the intersection point, 5 minus x is our top function. To plug this into your calculator, use math, then press 9, and then plug in all the values that you've written down. The answer is 2.985 units squared. In this problem, you earn 1 point for the integrand, which is the dx, 1 point for the limits, and 1 point for your answer. Another acceptable answer would be 2.986 if you rounded the last decimal point. Going back to the problem, we can see that part B wants region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. It's important to read the directions that say write but do not evaluate, so you don't waste your time. To find cross-sectional volume with squares, we use s squared. Again, we need to use two separate pieces, so that we can acknowledge both top functions. In this problem, we have the integral from 1 to 3.6934, quantity ln x squared dx, plus the integral from 3.6934 to 5 of 5 minus x squared dx. Remember that the problem says write but do not solve, so this is all we need to write. You receive 2 points for the integrands, which are the dx's, and then 1 point for expression for total volume. Part C says, the horizontal line y equals k divides R into two regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. You can see I've drawn an approximation of the line y equals k. To solve this, put both equations in terms of y. So the given equation y equals ln of x will turn into x equals e to the y, and the given equation y equals 5 minus x gets turned into x equals 5 minus y. Remember that your limits need to be in terms of y as well. So here we set the integral from 0 to k of quantity 5 minus y minus e to the y quantity dy equals the integral from k to 1.3066 quantity 5 minus y minus e to the y quantity dy. Or you could set the integral from 0 to k quantity 5 minus y minus e to the y dy equal to half of the answer from part A because that is the total area. In this problem, you earn 1 point for the integrand, 1 point for your limits, and 1 point for the overall equation, which can include one or two integrals. Some common mistakes include 1. Not writing the integrand in an integral, that's the dx or dy. 2. Not reading the directions. For example, write but do not solve. This will also waste your time on an AP test or a regular test. 3. Not going to 4 or more decimal places while you're working, as rounding too early will give you an incorrect answer. One that is not listed up there is showing all your work. So write out the integral on your AP test, because otherwise it's called a bald answer and you get 0 points for that. For more practice, visit textbook pages 420 and 430 to 432. That's 6.1 and 6.2 in the textbook. Thanks for watching.